Hi, everyone. My name is Albert Slepak. I'm part of Jonathan Apavo's lab, and today we'll be talking about demystifying USB and teaching the xHCI protocol from the ground up. So to give a bit of a background and context for where this project and ideas originated, about a year and a half ago, I started writing my own operating system, Stellax OS, that built upon the ideas done by Dr. Thomas Unger that graduated from Professor Apavo's lab about a year ago. And it explored the mechanism of dynamic privilege and fine-grained hardware privilege control in a clean slate kernel. Eventually, this work has also been awarded an SOSP Posters 2024 award and was presented at the conference last November. And as more features have been added and more testing and interaction with the system took place, before I did all of the testing in virtualization and in QEMU, but then I started running bare metal tests. And in QEMU, it is, as many of you may know, that it's very easy to interact with the system through serial lines. It's very easy to hook up your terminal to the COM1 serial port and just type in any input and it will go straight to the virtual machine. So it's very nice and easy. But on bare metal, there is no device input. On most modern machines like desktops or laptops, there's no PS2 controller emulation. So there's no easy keyboard shortcuts and input like that. So additionally, there's no serial lines on most modern consumer products. So you're stuck without device input. So what I realized is it's time to introduce USB support. I started Googling around looking for how to get started, where to approach this problem. And I've learned about xHCI, the Extensible Host Controller Interface. It's a modern interface for the modern USB controller that can handle USB 2 and USB 3 devices, and it's been used in most modern hardware that's younger than about 15 years old. So I had the keywords. I started Googling around and researching how to get started, how to write a driver for the xHCI controller, but there was literally no tutorials or any guidance at all on the entire internet that I could find on how to get started, how to approach this. And the only thing that was available is the Intel's xHCI specification describing how the hardware worked. And it was about 700 pages long in PDF reading, which was very overwhelming to start. And the Linux source code for the Linux xHCI driver, with each file being thousands of lines of code. And even though it was fairly documented, it had a lot of Linux-specific things, and it threw all of the information at you all at once, which was which made things even more confusing than before you looked at it. Nonetheless, I stuck with the Intel xHCI spec, and after many months of debugging and painfully reading it, trying to understand it, 1 year later, I had a working xHCI driver in Stellax. So I was able to recognize and detect connected devices in both virtualization and real hardware. And in these screenshots, you can see Stellax logs from the kernel identifying the connected QEMU mouse in virtualization. And the bottom two screenshots showcase my HyperX headset and a gaming mouse connected to the PC, and a bunch of information about the interfaces and protocols that these devices expose. So what I've learned through all of this journey and this process is that just because something is open source, like the xHCI specification or the Linux source code, doesn't mean that anyone can easily go in and understand what's happening. I wish there was this one other component, the explanation component. I wish that there was someone stood over my shoulder at some points and just helped guide me into which direction to go. Like, what's the chronological order of things that you have to implement, how to approach these problems. So that's when I decided to be that person. I wanted to lower the barrier for entry into writing these drivers and into understanding the xHCI protocol for other, especially beginner OS dev and hobby OS dev programmers that I've seen on forums, because traditionally it's been kind of the topic that everyone was either too scared of or considered way too complicated to start approaching, especially in the beginning stages of OS development. So I decided to create a YouTube tutorial series on xHCI driver development. With each video focusing on presenting the ideas in chronological order, meaning that especially in the xHCI spec, if you start reading it, a lot of the ideas are scrambled and it jumps around between different topics, and it doesn't present them in a chronological order at all. So does and neither does the Linux driver. All of the information is given to you all at once, and you have to spend a lot of time and effort parsing out and distinguishing how to build things chronologically. So this series aims at providing people who have never dealt with writing a driver before and have never dealt with USB and xHCI protocols in understanding how to build it from scratch. Additionally, each video uses custom-made animations and diagrams by using the Python framework command-m that you describe the scenes in Python, and it generates an MP4 file for you. And if you know a YouTuber, 3Blue1Brown, he makes amazing visualizations for math concepts. He uses he uses man-m as well for his visualizations. Additionally, the videos are structured so that first it presents the theory and the concept through these animations and diagrams, and then takes these theoretical concepts and shows how to put it into practice, writing C++ code-along style tutorial, basically coding it up live with the viewer, showing the chronological step of how to build things. And additionally, everything is documented in a GitHub repo. Each video tutorial having its own dedicated branch with documented commits showing which steps were done and took place. A huge focus was put into documenting everything heavily. So each C define or macro, or each structure that was defined that related to the hardware and the xHCI controller, it was heavily documented with citations and paragraphs taken straight from the xHCI spec, with the pages, section numbers, and all of the information straight from the spec. So it's easier to debug and look at it later. So let's talk about the xHCI components and what does the series look like. From what I've learned, there's 4 major components of the xHCI and how to approach it. First, there's the controller setup. Once you boot the computer, once you press the power button and the BIOS boots up, it takes control of the driver. It takes control of the controller and has its own xHCI driver, actually. It allocates a bunch of its own data structures and sets it up for its own use. But then once the control is passed to the operating system, you can't really rely on that anymore. Because these data structures are either inaccessible in memory anymore, or they just are misconfigured for your operating system. So you have to hold the controller and you have to fully set it up yourself with your own memory, with your own data structures, and initialize it for your own use. After that is done, there is the port management aspect. In this series, we'll talk about how to go from the physical ports in your computer or laptop, where you can plug in USB devices, to how are they represented in the xHCI controllers world, and then how to also abstract them into the kernel's driver, and how to represent that in software. Additionally, with the port management, you can either take away or provide power to the ports, so you can enable or disable them based on your power consumption requirements, and you can detect connected devices. Once you've detected a connected device, you have to set it up, and there's a lot of data structures that you initialized during the controller setup stage. You will be reusing them and configuring each device according to its port speed, according to its protocol, whether it's a USB 2 or USB 3. And this is arguably the hardest part of the whole driver. And finally, once you have the device set up, you have to manage it at runtime. You have to set up transfer rings, you have to set up communication buffers, and then periodically send requests to the device to get any information out of it. So interestingly enough, when I first started with kernel development, I thought that keyboards, just like the PS2 keyboards traditionally, whenever you press a key, they would send an interrupt to your kernel and provide you with an event to say, hey, I received a keystroke, I can now react to it. But that's actually not the case. And with USB keyboards and mice, or any HID device, You have to create a transfer ring, which is kind of like a bridge between you and the controller and the device. And you have to periodically put in requests, which whenever you press keys or don't press them, the controller will populate these buffers with the appropriate data. So if there's no keys that are pressed, it's just going to be all zeros. But otherwise, it's going to be 6 to 8 bytes of data according to the keys that you pressed. So let's now talk about the roadmap and how does the series and the YouTube tutorials take these 4 concepts and break them down into a sensible roadmap that the viewers can follow. First, regarding the controller setup, it first talks about what is an xHCI controller? Like, what are the requirements for the kernel to even start with this? And focus on mapping the controller from the PCI memory into the kernel's memory address space. Finally, then it resets the controller, halts its execution, clears any previously allocated data structures, and stops the controller. Then the focus is on setting up all the necessary data structures, like the device context base address array, I know a long name, DCBAA, which is responsible for later on storing device-specific contexts for each connected device. Then setting up the command ring, which allows you to communicate with the controller. And then finally setting up the runtime registers, interrupters, and event management data structures like the event ring. After all of that is done, the tutorials will cover how to start the controller properly. And if no errors have occurred during these steps, then the focus will be on anything in regards to runtime. This will be the next phase or the stage of the series. It will focus on actually communicating with the controller and sending it commands using doorbell registers, which are actually pretty cool. They're kind of like doorbells that you can ring. And just like a person opening a door and talking to you, the controller will respond, look at the command that you sent it, and provide you with a response object. And finally, for the runtime section, it would focus on port management, differentiating between USB 2 and USB 3 ports, because those are different in xHCI world. Even though they may be the same physically, depending on the type of device that you plug into the physical port, the xHCI will differentiate between USB 2 and USB 3 devices. And it will focus on detecting connected devices. Then it will be the hardest part and probably the longest videos, which will cover taking a connected device and fully setting it up, identifying what kind of device it is, setting up the input context, all of the transfer buffers and rings, control endpoints, and reading the device descriptor, which tells you what kind of device it is, the serial number, the power management settings, etc. And finally, to end the series and to provide the most rewarding part, it's going to focus on showing how to build a real keyboard and mouse driver on top of this, because it's not done all within the same driver, but rather a stack of them. There is the underlying xHCI driver, which manages the controller, and then drivers for peripheral devices like keyboard and mice can be built on top of that and are so much easier to build after you have done the base layer. So we'll show how to do that, and then how to take all of this from virtualization and apply it to real hardware to make it and focus on quirks and differences between virtualization and hardware, which even though they have been reported and they're not very commonly talked about, there's not much information on them, and they still haven't been fixed in QEMU. So there's differences between how you would approach things in virtualization and real hardware. And I want to make people aware of that so that they don't struggle later on. So now onto the progress so far. As of right now, I've posted 5 videos so far, and this is as of last night. And as of today, there's over 200 views on the first tutorial and over 100 views on the second one, with 50 views following the other ones. And it's crazy to me to think that they got so many views, because these are not my friends or people that I know that watch these videos, but I took the playlist link and posted it on a couple OSDev Discord servers and Reddit, and it was just random people from all over the world deciding to watch these and leave a lot of positive feedback overall. And if you go on YouTube, and I did this in incognito to erase any biases from cookies or cache, And if you search up the xHCI driver tutorial, these videos are literally the only ones that come up. So you can do that right now on your own side and see for yourself. And overall, the feedback that I received from Discord and YouTube has been um, overall super positive and encouraging for me to keep going. So as of right now, there's only 5 videos, but I'm currently working on the 6th one, and I will keep working on them until the series is over. Especially with all the overwhelmingly positive feedback that I got, is just so motivating and encouraging to keep going. And I think we're a little over time, so thank you all for listening. And if you want to check out the original Stellix repo, here's the link. So you can go in there, and if you want to leave a star, that would be much appreciated. I'll leave it up for questions.
Yeah, very nice work. Thanks,
Thank
Al.
you.
Did you just out of interest, did you try, I don't know, ChatGPT or something when you were trying to look through this?
Yes, I did. And it was actually the first kind of first point of contact, or the first step that I took to try to write it. And it was the worst experience ever because it very confidently started spewing out code that
Garbage.
was so blatantly wrong.
Yep,
And
yep,
it just led me down rabbit holes that if I just threw it all away and just sat there looking at my own code for a few more hours, I would have fixed it.
yep, yep. That sounds about right.
So generative AI is notoriously horrible in kernel development, so it's very hard to approach it even with these LLMs.
It's bad with anything with a very complex or large API
Yeah.
because it's it's not able to handle it. It has to, the way it generates it is it keeps feeding in tokens and into the entire side information that you're providing. So it's quadratic in the size of the input. Uh,
I see Professor Apavo has a question.
First, I just wanted to apologize for being late. My bosses are driving me like a
you should fire them.
so you know.
They're so annoying.
But there's a few things, not so much a question. I one just wanted to say what a pleasure it's been to have had a chance to work with Albert over the years. I'm sure most of you know, graduating and off out into the real world at this point. But it's really been a pleasure. And I think this last piece of work is one of those very fundamental aspects that we tend to gloss over with saying that the world is full of open source. There's a far cry between open source and knowledge and understanding, and the discipline and the desire to actually say, no, I can take this open source material and actually help people understand the underlying bits, because if it's just magic and we just take it for rote, it's not necessarily any better. And so it's been really inspiring to see this. And I have to also say that in terms of undergraduates being able to make forward progress on from scratch kernel work, Albert has been 1 in a million. So again, thank you, Albert, for giving me the opportunity to work with you.
Thank you so much. I couldn't have done it without you and all of your support and all the collaboration with your lab.
I just can't resist a note, Jonathan, that I'm not sure that this is a bug of open source. It might be a feature, right? The whole point is to have people who are experts who can help you if you want to do something deeper.
Yeah, the danger is that at least what we've seen a lot in the kernel, the number of times that people don't know at all why the code works anymore or how it works.
Well, yeah, that's
and
true.
Despite all of the availability, the magic constants, and I really encourage folks to look at the code and how it's written with the very precise care to cite every document, every page, every line for why the settings are the way they are.
Yeah. Oh, very nice. So how many did you complete, Albert? How many of the tutorials?
So there's five videos up already, and the 6th one on the runtime register should be up either tonight or tomorrow night.
Okay. So you're planning to continue with this and finish?
Absolutely.
Okay, very nice.
now that I've gotten some good feedback from everyone, I feel almost like a responsibility and obligation to keep going and not stop.
Yep, sucks you in. Very nice.